Okay, so we come into a bar chart. So however we do the analysis, it's nice to see the results in a bar chart, because you will see that you can interpret more things when you see it in a bar chart. So this is the same results in a bar chart, where you have activity, you can see A, B, C, D. Okay, activity A takes 5 days, you can see it's start of the first day to end of the 5th day. Okay, activity B, it's in light blue here, it starts activity B and C. Now you can't see the relationship logic here, okay, but because we have got the results out of the CPM, we can put it into the bar chart, and here's B starting at the beginning of the 6th day, okay, ending end of the 9th, okay, as it's put there. Activity C, okay, finishing at end of 11, and activity D starting at beginning of 12 and going all the way to 14. Okay, now we have seen that this is what we call, there is activity B, so this is the early start schedule. Now if I go to the late start, what happens?
B.
Yeah, so I can move B, the only thing I can do when I move to late start is to move B by to all the way to 11, and if I move B all the way to 11, is the project is still okay. So I can visualize the late start schedule also on the bar chart, okay, and as we get into more complex networks and schedules, you will find that the ability to move in the bar chart, the ability to move an activity around between its late start and its early, or gives us a lot of flexibility in where resources are to be allocated. So we will use this a lot more in the resource allocation feature. Any questions? Okay, so let me give you another problem to do. Okay, this is a slightly larger network. Okay, activities A to H, you have the duration, you have the predecessor. Can you do the analysis for this network? Done? Okay, so let's go with the network. So I have activity A, B, C, D, E, F, G, H. So my relationships are B follows A. Okay, so these relationships are seen by wherever I have this. So I have B, C and D with A as a predecessor. Okay, now I have E here, it has both B and C as predecessors, and F has C and D as a predecessor. Okay, now I come to G, it only has D as a predecessor. I come to H, it has E, F and G as predecessors. Okay, so this completes the network. So what the predecessor relationship to the activities have been represented here. Now we put in the durations as we did it manually. I am using the same notation here. I have all the durations now along with all the activities, and now I start the forward pass. So with 0, 5, and now all of these can start at 5, and this would go to 9, 12, 13. So now where should E? 12, okay, because its predecessors are B and C. C only finishes by 12, so it has to go to 12, and then F has 12 and 13 as predecessors. Okay, so it's 13. G has it's only 13 as a predecessor. Now E will finish at 18, 16 and 23. So now H has 3 predecessors, and we have to obviously start with the last one, okay, the one with us, okay, and then finishes at 27. Okay, any questions? So now if you wanted to come up with a way of, so what we did here is a forward pass, and what we calculated was the early times, right? We calculated the early start and the early finish. What would the formula, if I wanted to come up with some kind of formula, what would my formula for early start and early finish be? Either predecessors or successors.
Early finish of all the predecessors.
Right. So basically it is max of early finish it's not a formula but it's a notation, right? What about early finish? Early start plus duration. Okay, so this is the logic you are applying to calculate this, and the only place the logic gets tricky is when you have to find out what is my maximum of predecessors, and when you get a complicated network, have I actually calculated all my predecessor parameters. Okay, now we move to the go on to the backward pass. So we will find that this has to complete on 27. We are fixing that, working backwards goes to 23. So what is the latest finish? Yeah, so all of this can finish as late as 23 without compromising the project duration. Okay, so all of this can finish as late as 23, and now I again calculate back to the late start. Okay, so when I am calculating backward pass, we first calculate the late finish, then go to the late start. So I have 17, 20, 13. Okay, now I come to B, late finish, 17. C has 2, it has 17 and 20 as successors, 17. Okay, D has 20 and 13, 13. Now further back to the late starts, 13, 10, 5, and A now has 13, 10, 5 as successors, 5, 0. Okay, so now I am going to ask you obviously for the late finish equal to, yeah, minimum of late start okay. So this, any questions on this? Okay, so here you have all of the parameters. Actually I should take you back here and ask you, so we know project duration is 27. You can make out what is critical here without any calculation, right? Which is the critical, what are the critical activities? A, D, G, H. Okay, and you can see in ADD in this chain of activities, all of the early parameters and the late parameters are the same. That means any delay to any of these activities will delay the project. Whereas on the other chain, there can be delays by varying degrees. Okay, and this is really the subject of a lot of discussion, which we will take up when we discuss the slacks and floats. Now, the same project can now be represented in a bar chart. Okay, same results can be represented in a bar chart, and the activities in pink are the critical activities. Okay, the others you can see the amount of delay they can have. But can I, for example, start moving one of these activities all the way to the end? What will be the impact? Yes, the succeeding activity will have to get delayed only then. So if I delay, for example, B, okay, and I go back to the network, obviously it will impact E. Okay, so if I delay B here, E will also move down, right? I cannot delay B without after, I mean beyond a certain stage. So how much can I delay? So here is an interesting question. How much can I delay B without delaying E? Without delaying E. So if I am going with my early finish is 9, early start is 12. So I can go 3 days from the early parameters of B without delaying E. If I go 4th day, E will start getting impacted, okay, unless I of course move E all the way to start out 17. So there is a lot of play here which project managers use to be able to schedule resources, to be able to, if they have to share resources between activities, this is the kind of play they use, and this is all about slack or float, and this is something one has to understand very well to be able to utilize resources effectively on a project. Okay, so now here is the early start schedule of this project, and here is the late start schedule. I don't think that has come up. Okay, yeah. So we discussed this also. We had the forward pass. We discussed these two formulae. We also discussed the backward pass, and we right now identified critical activities because the networks were simple and we were able to easily see which activities were critical. But in the next lecture, what we'll talk about is, we'll complete some of these issues in more detail. We'll talk a little bit about sequencing, but we'll take up the important issue of floats and discuss that in detail. Any questions? Okay, thanks.